What does it take to develop an effective climate change curriculum? The presentation addresses this question by first presenting 4 literary approaches for addressing climate change curriculum. It continues to critically analyze 2 curricula, the Next Generation Science Standards and the Climate Change Curriculum in the New Jersey Student Learning Standards. The discussion addresses the following points: problematizing climate change inclusion through a cross-curricular approach, key socioeconomic, political, ethical concepts underpinning climate change articulation, thematic organization, the importance of nonlinear climate change thematic organization, terminological inconsistency, giving consideration for learning progression and selection of age-appropriate contents, and finally, recommendations are drawn to inform the development of climate change curriculum. Education ministries across the globe are increasingly called upon to educate students about climate change, undoubtedly the most urgent and complex threat to life on Earth. In responding to these bottom-up calls, increasingly departments of education are realizing their role in preparing students to live and thrive in an era of climate change. An educational era which was also described as education for the end of the world as we know it. In addressing this immense challenge, this presentation addresses the question of what does it take to develop an effective climate change curriculum. Specifically, the objectives are to critically analyze 2 existing climate change curricula, identify gaps in climate change curriculum development, and point out critical issues that need addressing in climate change curriculum development. The literature concerning climate change curriculum development can be grouped into one of the following 3 types: studies discussing general ideas that need to be present in climate change curriculum without specifying content and concepts constituting the curriculum; studies specifying the science concepts relevant to climate change processes, however failing to specify critical non-scientific concepts responsible for causing climate change and inherently implicated in climate change processes; and studies presenting thematic organization of climate change, however the concepts are not specified. Many publications present general aspirations for climate change curriculum without specific contents description. For example, UNESCO, in a publication entitled Getting Climate Ready, A Guide for Schools on Climate Action, calls for the inclusion of environmental, economic, social, cultural, ethical, political, scientific, and technological issues in climate change education. Cantell and colleagues developed a model to demonstrate what the authors regard as the essential aspects of climate change education. The model uses a bicycle as a metaphor for representing 10 aspects: knowledge, thinking skills, values, identity, worldview, action, motivation, participation, future orientation, hope, and other emotions, and operational barriers. Both examples do not provide content specification. Some attempts were made to specifically outline the science contents in climate change education. For example, in 2009, several leading USA science organizations, scientists, and educators created a framework entitled The Essential Principles of Climate Science Literacy. The 7 essential principles are: the sun is the primary source of energy for Earth's climate system. Climate is regulated by complex interactions among components of the Earth system. Life on Earth depends on, is shaped by, and affects climate. Climate varies over space and time through both natural and man-made processes. Our understanding of the climate system is improved through observations, theoretical studies, and modeling. Human activities are impacting the climate system, and climate change will have consequences for the Earth system and human lives. The framework has a few limitations. Firstly, it focuses on the scientific aspects of climate change only, neglecting the humanistic aspects. Secondly, it does not differentiate between change in the climate over geological periods and the current human-induced climate change. Finally, it uses the terms climate and climate change interchangeably, thus failing to make a critical distinction between climate, which is studied in the discipline of climatology, and climate change, which is a term that describes the range of human and non-human interactions causing the anthropogenically induced climate change. Shepardson and colleagues developed a detailed content description for school curricula based on the science of climate change. Their climate change content scoping is guided by 3 questions. 1. What is a climate system, and what are the components of the system? 2. What happens to the system when components within the system change? And 3. What are the impacts of these changes? Additionally, the framework provides learning progression across 3 levels of conceptual development. To the best of knowledge, this is the first systematic attempt to address the issue of progression points in climate change curriculum. However, similar to the essential principles of climate science literacy by the Global Change Research Program, this framework is also incomplete because it specifies only the science contents related to climate change. To develop a complete climate change curriculum, there is a need to include socioeconomic, governance, ethics, concepts, and paradigms that give meaning and trajectories to climate change processes. However, these often appear as undefined invisible forces. For example, Shepardson and colleagues' framework states we enhance the greenhouse effect by changing the carbon and the broader biogeochemical cycles through changes such as burning fossil fuels or changing land cover. Here, forces that have the power to enhance, change, and burn remain invisible. Evidently, there is a need for further curriculum development to name the key socioeconomic governance ethical driving forces, explain them, and bring them to the forefront. In a 2020 publication, we propose to scope climate change contents along a continuum ranging from science perspectives to humanity perspectives. 8 themes were identified along this continuum: observed changes in climate, drivers of climate change, future climate change, risks and impacts, adaptation and mitigation, socioeconomic, policy and governance, and ethics. Each theme is based on fundamental key questions and essential content knowledge. Only few studies conducted in-depth analysis of climate change in existing curricula. One such study was conducted by the National Center for Science Education and the Texas Freedom Network Education Fund in 2020. They evaluated climate change in the science curricula of the 50 USA states. The quality of climate change representation was given a grade ranging from A to fail. Only 1 state received grade A, 6 states failed. The NGSS itself received B+. The author noted recurring problems, including promoting a false debate, avoidance of clearly naming climate change when addressing climate change issues, muddling the science by using ambiguous wording, suggesting unclear evidence, The authors caution that even states that received grades A and A- require improvements in their climate change education. Overall, the literature review suggests a reductionist and unsatisfactory approach to climate change curriculum development, where key concepts, if identified, tend to address the science basis only and disregard the humanity basis that gives explanation and meaning to the current state of climate change. To gain in-depth understanding about the missing pieces in climate change curricula, I conducted an analysis of 2 curricula. Finding a curriculum for analysis was not a simple matter. Worldwide, there is dearth in fully developed and rationalized climate change curricula. Consequently, I found only one fully developed climate change curriculum available in English. This was the climate change curriculum of the state of New Jersey in the USA. The New Jersey curriculum adopts the Next Generation Science Standards as its science curriculum. The Next Generation Science Standards form the main curriculum framework for teaching science and engineering in the USA. Consequently, these 2 curricula were selected for analysis. An NGSS standards would look like this. The performance standards reflect the integration of the 3 dimensions, specifying the knowledge and skills that students need to be able to demonstrate at a given grade level or across a grade band. Climate change is incorporated in the NGSS as a recommended concept within the disciplinary core ideas and in most of the cross-cutting concepts. However, the topic of climate change only appears explicitly in Earth and Space Science in 1 standard in middle school and 4 standards in high school. Foundational climate-related ideas such as the carbon cycle appear at every level from K to 12 across the 4 disciplinary core ideas. The NGSS primarily focuses on the science aspects of climate change. Science concepts are introduced through a learning progression beginning in grade band 6 to 8. Detailed analysis revealed 4 aspects of ambiguity. First, there is a lack in clear distinction between the anthropogenic climate change and changes in climate over geological timescales. This is exemplified in Earth Materials and Systems, stating that the geological record shows that changes to global and regional climate can be caused by interactions among changes in the sun's energy output or Earth's orbit, tectonic events, ocean circulation, volcanic activity, glaciers, vegetations, and human activity. Such lack of distinction may lead to the erroneous conclusion that current anthropogenic climate change involves non-human caused factors. Second, while the NGSS is successful in addressing key scientific concepts in climate change, these concepts appear scattered across various topics and are disorganized. The lack of conceptual organization leaves teachers and students on their own to integrate the various climate change concepts. Third, the curriculum fails to identify 9 science-based key concepts in climate change and address them comprehensively and systematically. These include, for example, concepts relating to economic models and forms of governance, which are key for understanding climate change. The 4th concerns relate to terminological inconsistency and incoherency. Various terms related to climate change are used in ways that may be misleading. Finally, in my view, a critical question must be raised as to whether the science curriculum can and should accommodate climate change education in the first place, or whether climate change requires a curriculum of its own, in which science is included as one theme. I believe this question is the elephant in the room, forming the main obstacle for developing quality climate change curriculum. Previous studies highlighted further strengths and weaknesses in the NGSS. For example, Johnson and Anderson concluded that this climate change curriculum is not enough to prepare students for civic engagement around climate change. Students must also recognize the limits of science and appreciate that value judgments and political and economic concerns are also important aspects of the discourse around climate change. Unfortunately, the social context receives little attention in the NGSS. Furthermore, they claim that because they ignore issues of how climate change affects human societies and environmental justice, the NGSS performance expectations fall short of describing the knowledge and practices students will need to be ethical and effective decision makers about climate change related issues. In June 2020, the State Board Education adopted the 2020 New Jersey Student Learning Standards, making New Jersey the first state in the USA to incorporate K-12 climate change education across content areas. The enactment of the new standards began in September 2022. Climate change is conceptualized as a multidisciplinary topic appearing across all content areas in a cross-curriculum approach in grades K to 12. The curriculum does not provide a rationale or justification for its cross-curriculum approach. There is a conspicuous lack of consideration of alternative options for climate change inclusion and the use of best practice evidence for guiding the selection of an inclusion approach. Such considerations need to appear upfront to allow debate and evaluation. The findings identified areas of strength and areas for further improvement. An area of strength includes consistent use of the term climate change across the curriculum. With the current tendency of the media to use catchy sensational terms, this curriculum may be commended for its overall consistency in climate change terminology. In science, the early year bands are dedicated to establishing foundational science knowledge where specific climate change contents are gradually introduced in grade bands 6 to 8 and become more specific and complex in grade band 9 to 12 in both science and social studies content areas. Areas requiring further development include lack of content organization, lack of content specification in all content areas excluding the science and social studies. At the declarative level, the curriculum aims to apply the cross-curriculum approach. However, at the implementation level, climate change contents appear only in science and social studies. In all other content areas, it appears as a title only. In the lack of content descriptors, it seems that teachers and students, as early as in foundation years, are left to select their own climate change contents. This is a cause for concern because by leaving students to select their own climate change contents from the media, students may be put at risk of developing inaccurate climate change conceptions and developing climate change anxiety. This approach may be counterproductive as it enhances the negative effects of the media rather than placing schools in a remedial role. Lastly, the limited content scoping and internal organization across K-12 appears to result in limited attention to learning progression across years and between content areas within grade levels. Learning progression was noted mainly in science in relation to the science basis of climate change. However, progression was not apparent in other content areas. For example, children in Foundation to Year 2 are expected to investigate a global issue such as climate change, its significance, and share information about how it impacts different regions of the world. This performance expectation is clearly not age appropriate due to its high level of epistemic complexity. Similarly, students in years 6 to 8 are expected to be able to analyze complex climate change models and even refine them. While this could be an appropriate expectation from university students, it is not conceptually appropriate for years 6 and 8. Overall, further work required in developing thematic organization, identification of key concepts, and progression points across year bands. The curricula analysis revealed a few gaps, which I will discuss now. The cross-curriculum approach for including climate change in the curriculum is the most advocated approach. However, theoretical and empirical evidence clearly indicate that the approach is ineffective. The roots of this approach may possibly be traced back to the assumption that if climate change is a multidisciplinary field of knowledge, it follows that it needs to be implemented in multiple school subjects. This conceptualization is problematic in two ways. First, by giving the false impression that multidisciplinarity is a distinguishing epistemological descriptor of climate change, and second, by assuming that effective teacher of multidisciplinary knowledge is by dispersing it across the curriculum. The fact is that multidisciplinarity is a non-distinguishing epistemic characteristic of knowledge. This is because most knowledge produced by humans is essentially multidisciplinary. Science, history, civics, they all can be characterized as multidisciplinary. And thus, multidisciplinarity on its own is not helpful in characterizing climate change as a body of knowledge and distinguishing it from other bodies of knowledge. Regardless, while we do not go about dispersing history or science across the curriculum, there seems to be an agreement that this approach is a good idea when it comes to climate change. This form of fragmentation and dispersal of climate change across the curriculum was criticized for posing a range of hindrances for effective teaching and learning, including challenges to curriculum design and implementation, resources development, teaching and teacher knowledge and learning. In fact, subject-based curricular structures are particularly suitable for addressing complex knowledge such as climate change. For this reason, we find that in most countries' upper secondary curricula, where concepts are more complex, the curricular organization tends to be more subject and disciplinary based compared to the lower years curricular organization. Empirically, it was found that regardless of the advocacy of the cross-curriculum approach, few countries apply this approach in their curricula, and when they do so, it scarcely filters down into actual implementation. The current study supports these findings. The review of the New Jersey climate change curriculum reveals that while at the declarative level the aim was to include climate change in a cross-curriculum approach, effectively climate change contents appeared only in two learning areas, science and in social studies to a limited extent. In all other content areas, climate change appeared as a title lacking contents. Literary attempts to explain the gap between the cross-curriculum advocacy and its limited implementation success usually tend to lay the blame on the curricula, schools, and teachers for not trying hard enough. However, the lack of success is grounded in educational theories, and it is the most likely expected outcome. The lack of theoretical basis and empirical success of the cross-curriculum approach suggests that climate change education is more likely to achieve its goals when implemented as a subject on its own right, with dedicated teachers trained to deal with the complexity of climate change in a systematic way. Repeated findings from both the literature review and the curricula analysis indicated that key concepts in the humanities basis of climate change are mostly missing. This is contrary to the science basis of climate change, where key concepts are identified and presented in a relatively organized way. To develop a complete climate change curriculum, it is essential to identify and organize key concepts in humanities. This is because the humanities basis of climate change is the only basis that could provide valid explanations for the state of climate change and its future projections. The science on its own cannot provide explanations for many aspects concerning climate change. Fields of knowledge are made up of concepts, each having its own explanatory power. Concepts form important structural foundations of curricula. They provide the cognitive tools for unpacking complexity and understanding the principles of knowledge assemblage, production, verification, and evaluation. Some concepts are governed by natural laws, such as the concept of atom or a conceptual process, such as conduction. However, some concepts in the humanities describe typifying characteristics of operation or relationships, such as the concepts of free market and democracy. The understanding of concepts allow the learners to generalize and explain phenomena. For example, understanding the concept of free market provides a framework for explaining other phenomena, such as why the growth of nations' GDP is accompanied with the growth of inequality. The lack of key concepts in humanities is a critical omission from climate change curricula, leaving it incomplete and not fit for purpose. For example, to understand the exponential rise in global CO2 emissions since the second half of the 20th century, there is a need to understand the economic paradigm shift occurring at this period, from the Keynesian economy to the neoliberal free market economy of the Chicago School of Milton Friedman. Among the various impacts of this shift was the opening of markets for free trade and governments stepping back from their regulatory roles, consequently creating the conditions that allowed CO2 emissions to rise unabatedly. Curricular reliance on science alone evades critical questions in climate change. The following NGSS statement is an example of this oversight. Changes in the atmosphere due to human activity have increased carbon dioxide concentrations and thus affect climate. The empty statement, human activity has increased, does not explain why emission growth was slow for over a century post the Industrial Revolution and had quadrupled by 1990. While science does not hold the answer to this question, understanding the economic paradigm shift and its wider implications do hold the answer. Another example for the need to develop a fully conceptualized climate change curriculum relates to explaining the 30 years time lag in implementing measures to curb carbon emissions. By 1992, when world leaders gathered at the Earth Summit in Rio de Janeiro, the science of climate change was clear and consensual. The massive burning of carbon-based fuels is destroying the climate balance and threatening Earth life support systems. However, 30 years later, emissions are still rising. This begs the question, why? Arguably, if the matter was only an issue of understanding the science, then climate change could have been dealt with as effectively as dealing with the ozone depletion. Here again, science does not hold the answers. To understand the 30 years time lag, we need to draw upon social science explanations about the ways in which the fossil fuel companies organized and strategically orchestrated deception and manipulation campaigns to prevent action on climate change, and understand the economic political structures that allowed the denial industry to propagate unaccounted for within enabling legal frameworks. These two examples highlight the need to position climate change education on its appropriate footings. Climate change is not a field of science, nor can it be explained on science basis only. Scientific explanations form only a limited subset of concepts constituting climate change. The humanity aspects of climate change require articulation. Currently, they tend to appear in curricula ambiguous and unexplained. For example, reducing the level of climate change and reducing human vulnerability to whatever climate changes do occur depends on the understanding of climate change engineering capabilities and other kinds of knowledge, such as understanding of human behavior. This ambiguity related to other kinds of knowledge and human behavior requires explication in effective climate change curriculum. Thematic organization is a key curricular instrument for organizing information for teaching and learning. Themes assist in breaking down of complexity into smaller units. Themes provide organizational structures for key concepts. Often, there is a narrative connecting the concepts within themes. For example, the table of the disciplinary core ideas in the NGSS presents a form of thematic organization of core ideas in the science curriculum. Here, each branch of the science is broken down into themes and subthemes. For example, the theme, matter and its interaction, includes 3 subthemes: structure and properties of matter, chemical reactions, and nuclear processes. In a history curriculum, thematic organization may consist of historical periods or history of different regions. Unlike the detailed thematic organization that we find in most curricula, climate change curricula stands out in having no thematic organization, mostly presenting one theme only, that is, a climate change science theme. All other matters concerning climate change are bundled, glued together on the edges of the science theme, lacking concept specification and thematic narratives. When it comes to understanding complexity, the evidence suggests that students required explicit thematic organization to support the conceptual development. Leaving students and teachers on their own to unpack the bundled humanities aspect with all its complexity is a difficult task for experts and much more for teachers and students. Organized climate change information is required to enable students to effectively integrate multiple concepts in science and humanities into coherent epistemic explanations in climate change. However, thus far, there has been a dearth of information in scholarly work proposing thematic organization for climate change curricula. A word of caution is required concerning organizing climate change curricula in a cause-effect linear form. This can take, for example, the form of causes of climate change processes, effects and impacts, and solutions. The linear organization causes the flattening of climate change body of knowledge. It reduces its complexity and ignores multiple thematic narratives that are cooperative in the system in multiple directions and influences. Additionally, a linear thematic organization tends to focus on the science aspects only. For example, under effects and impacts, the discussion of impacts on humans can take the following form. Coastal regions will be impacted by rising oceans and, according to some studies, a possibility of more frequent hurricanes. Prolonged heat waves and drought conditions will stress water and food resources and cause most heat-related deaths. Hotter days would result in poor air quality and increased ozone alerts. People may be required to change their lifestyles and practices to mitigate global warming, and communities may need to become climate ready, preparing for increased flooding and storm and drought conditions, which may require changes in zoning, land use practices, and agriculture. The projections taken from Shepardon and colleagues' publication, these projections are reflective of a science-based theme. However, a more comprehensive picture emerges when effects and impacts are viewed across multiple themes in a nonlinear form. For example, the economic theme may tell the story of the tragedy of the commons described by Hardin in 1968. The idea suggests that in the absence of strict regulations and enforcement, common resources such as air, water, soil, or pasture for cows, in the case of Hardin's metaphor, are destined for depletion. The current economic paradigm created the perfect conditions for the climate change tragedy to unfold. In the neoliberal free market economy, many common resources cease to be common through privatization. Additionally, governments allow and encourage corporates to freely exploit both privatized and the commons through favoring governmental regulations. Consequently, the free market economy increased inequality in resources distribution, creating social anomalies of exorbitant concentration of wealth among a small population versus extreme deprivation among a growing sector in the population, even in countries as rich as the USA. When it comes to climate change effects and impacts, we find that societies with extreme inequalities are less resilient to climate change calamities, and that the effects and impacts of climate change differ greatly between different groups within societies, overall leading to a situation in which those who contributed the least to climate change suffer the most. Finally, to demonstrate the importance of developing nonlinear thematic organization of climate change curricula, it may be helpful to think of what other subjects might have looked like if such an organizational approach was applied to them. Imagine, for example, organizing the subject of biology as follows: cells, organisms, ecosystems, biosphere. While linear narratives are helpful in connecting concepts within themes, reducing the entire field of climate change into one linear theme is evidently over-reductionist. A simplistic cause-effect linearity leaves out critical concepts and themes that are important for developing comprehensive understanding of climate change. The analysis of the NGSS reveals terminological inconsistency and incoherency. Some national policy documents and scholarly research use the terms climate education, climate literacy, carbon literacy, climate crisis, and climate science literacy. Additionally, it is commonly conceived as a theme within multiple other fields such as education for sustainable development and global citizenship education. The use of terms such as climate education or climate literacy may give the erroneous impression that climate change is equivalent to climatology. While climate change includes climatological concepts, it goes beyond climatology. For consistency and clarity, it is recommended to use one term. The term used by the IPCC is climate change. This is the most scientifically accurate name, and curricula should be using it. Learning progression forms an important aspect in curriculum development where the progression of students from novice to experts advances along conceptual progression. Learning progression includes signposts for aligning standards, instruction, and assessment. Additionally, it plays an important role in ensuring age-appropriate delivery where the concepts taught are appropriate for students' levels of cognitive and emotional epistemic development. Regardless of the importance of learning progression in curricula, this issue is only scarcely addressed in relation to climate change curriculum. The curricula analysis revealed duality in relation to implementing learning progression. The NGSS includes clear learning progression in relation to the science aspects of climate change. However, all other content areas in the New Jersey curriculum did not include learning progression. It was also found that some of the standards in the New Jersey curriculum were not age appropriate. In climate change education, it is particularly important to develop learning progression. This is because exposure to inappropriate contents at an early age may be harmful to students' well-being. It is imperative that concepts be built on existing concepts systematically using age-appropriate pedagogies. Based on the analysis, a few recommendations may be drawn for future climate change curriculum development. The relationships between climate change and science is that science forms a theme of climate change and not the other way around. That is, climate change is not a theme of science. The cross-curricular approach to including climate change is theoretically unsubstantiated and empirically ineffective. It is recommended to include climate change as a standalone subject or topic in the curriculum. Climate change curriculum needs to be organized by themes with connections across themes. Themes include concepts, and these are connected through narratives. A complete climate change curriculum needs to identify learning outcomes related to both contents and skills acquisition, set performance expectations, and forms of assessment. There is a need to develop learning progression across themes and/or within themes as appropriate. Climate change is probably one of the most complex fields taught at school. It requires sufficient conceptual development and emotional preparedness by the students for dealing with climate change issues. It is recommended to give careful consideration to the selection of concepts in an age-appropriate way. Hopefully, the application of some of these recommendations will assist in developing an effective resilience-building curriculum. Thank you for listening to this presentation. A suggested citation may be found here. And these are the list of references used for developing this presentation.